Hi, and welcome to the sig fig rules video. There are also some examples that I'm going to go through in this video so that you can get a little bit more familiarity with this topic. Of the topics in the summer assignment, this is definitely one that most of you have not seen before, so this is purely a new topic for you, so I just want to make sure it's outlined very clearly. When we are measuring things in the lab or reporting information to other scientists, we do have to be really clear about the information that we're reporting and making sure that we're, not making up any numbers or telling something that we really couldn't measure in the lab. So if you're in the lab, you read all numbers, you don't make things up, and anything you read, if you read something off of a balance and it's 0.25 grams, those numbers are significant figures. So anything that is clearly seen on a balance, on a graduated cylinder, counts as a significant figure. If you're looking at a number that is given to you on a piece of paper that is a measurement, you're to assume that any number that is not a zero counts as a significant figure. So if you have 1.25, those are all not zero, so they all automatically count. Now, zeros are where it gets tricky. So some zeros count, some zeros don't. What's called a middle zero count. So a zero that is between two non-zero numbers. So in 3A, the measurement 303 millimeters has 3 sig figs. All of those count. So that zero automatically counts because it is between two numbers that are not zero. What we call leading zeros do not count. So in this particular measurement, those numbers count, those numbers don't. So this has 3 sig figs. Now this is bothersome to some people. I'm actually going to take that off of there for just a moment. 3 sig figs here. This is bothersome to some people because you're like, well, if you take that zero out, it's 0.123 instead of 0.0123. But keep in mind, if we were truly writing this like a scientific document, we would actually show it in scientific notation. You don't see people like throwing this zero there in scientific notation. Since that zero goes away essentially in scientific notation, it is not considered a significant figure. It is what we call a placeholder. Now, trailing zeros are the very trickiest of all zeros. Trailing zeros count at certain times and don't at others. If a trailing zero comes after a decimal and a non-zero number, so it has to come after both of those things, then it counts. So 23.30 milliliters has 4 sig figs. Now, one of the things that's also important to understand about sig figs is they are a communication tool. Their rules are not mathematic in nature, they're communication based in nature. So if we look at the measurement 230 milliliters, if we actually measured exactly 230 milliliters, or as close to exactly 230 milliliters as we could, and if we had a device that allowed us to, an instrument that allowed us to actually see, here's the 230 line, and there's my meniscus, that's 230. We need to be able to tell people that it's not 231, not 229, but we know that it's 230. On the other hand, if we had a piece of equipment that was not that precise, we might want to say it's close to 230, but it might be 232. So in this first measurement right here that does not have a decimal written on it, this is only 2 sig figs. Our second measurement over here, or down here, that decimal makes all of those count. That's very bothersome to some people. It is a communication decimal, not a mathematical decimal. Anything that's given you in scientific notation automatically counts. I don't particularly like this example very much because it's not proper scientific notation, but if you have 2.3 times 10 to the negative 4, all of those count. So that's 2 sig figs. When I say all of them, I just mean in the number base, not the exponent or the 10. If you want to really, if you had a measurement that was like that, all of those automatically count. I mean, those are trailing zeros, so they would count anyway, but, there's no thinking about scientific notation. We would assume, 1, 2, 3, 4, 5, 6, that's 6 sig figs. There's also a little weird thing with sig figs where there are things that we consider exact numbers. So if you're talking about an exact number, we're talking about a countable quantity. So if we wanted to count how many people are in this room, and or like pretend we're in a classroom, we've got a class of 20 students and 1 teacher. we can count that there are 21 total people, and that number has what we call unlimited or infinite significant figures. And this becomes important when we're actually doing math. So I'll give you a quick example of this in a minute. So, you can count people. There's not going to be an argument, oh, I think there's 21.5 people in the room. I think you counted wrong. There's a half person missing. You may consider that some people are, more of a person than others. I don't know. But in reality, each person counts once. Same thing if you're talking about eggs or if you're talking about any countable quantity. So where this comes into play is with the rule for dividing. So if I had 233.567 grams of gold, and I was going to divide it by the 21 people in the room, what I get on my calculator is 11.1222381. Now, how many significant figures am I going to report in this? So I plugged in two numbers. One of them was this number, which has 1, 2, 3, 4, 5, 6. As you saw in the Khan Academy video, when we multiply and divide, we are limited to the number we plugged in that has the least sig figs. So you have 6 there. Now the number 21 technically is 2, but in reality, it's infinite. So because of that, when we look at our value in our calculator, we're going to keep 1, 2, 3, 4, 5, 6 sig figs. So we would actually round to right there. And our properly reported answer would be that each person gets 1.1222 grams of gold. So a few significant figures questions for you to try. You can pause the video and I'll pop the answers up for you. So I did throw a little trick at you on the first one. And, from Earth science, maybe like, well, I don't know if that's really exact because of leap year and etc. But in terms of countable seconds, there's 60 in 1 minute. So we do consider that to be unlimited. In the measurement of gold, so that's not going to be unlimited because it's showing that it's a measurement. All of those count. This is a trailing zero. It is after both a decimal and a non-zero number. So that one counts. Next one is a lot of sig figs also. It's a measurement, it has milliliters with it. All of those zeros count. Sandwich zero, sandwich zero, sandwich zero, and trailing zero. And that trailing zero there, all of those zeros are counting. Her hair is almost 350 millimeters long. Only these count. This one does not because we don't have a decimal following it. If you measured it and it was exactly 350, you would have to put a decimal there and then have 3 sig figs. The road being 0.0950 in length, these 3 sig figs count. These are what we call leading zeros. Rounding to sig figs is important as well. So when you're rounding to sig figs, and I just picked 3 here, this kind of depends on the particular problem that you're doing. So you start all the way to the left at your first sig fig. So if I start here on this one, 3 sig figs mean I have to round to that tens place. And then you follow your regular rounding rules. So this would round to 98.5. On this next one with the decimal, we actually would start here. So we're keeping those sig figs. And you would round this to 0.000763. If you're more comfortable changing that into scientific notation, you would just do this. Sorry, count that out for a second. So I'm going to give you just a second to try 3, 4, and 5. So there's your answer on each of these. Some people get bothered by 3 because they really, really, really want to use that 8 to round that 4 up. But you do not do that because you're just basing this on the 4.048 is actually closer to being rounded down than up because it hasn't hit that 0.5. So when we round this, we do now have 3 sig figs. Remember that 0 does count because it's a trailing 0 after both a non-zero number and a decimal. There's each of your other ones. In number 5, you do not want to put a decimal here because if you do, then you end up with 4 sig figs. So the math with sig figs, whenever you add or subtract, you are limited to your least number of decimal places. Sig figs do not matter. So take a minute, try each of these, and then I'll put the answers up for you. In each of these, I showed your calculator answer, and I'll just kind of outline where you're limited. 19 has no decimal places, so you can show none in your answer for the first one. For number 2, we have, I messed up number 2. Hold on just a second. In this one, we actually have 2 decimal places there, so I should have kept 2 decimal places. So this is going to be 54.29. My apologies. The next one, we're only going to have 1 decimal place because of this. Oh, never mind. Sorry, I forgot we were multiplying here, so that is a different rule. In multiplication, I'm sorry, it is based on the least number of significant figures. This one has 3 sig figs, so when we multiply and divide, we're limited by sig figs, since decimal places can move, so I'm sorry, that is correct. Number 3, we're limited by our decimal place. We have 1 decimal place there, 1 decimal place here. Last one's dividing, so we have 3 sig figs in this answer, and therefore 3 sig figs in our answer to number 4. Sorry about the confusion there. So that's the end of our sig fig video. We will practice with this a little bit in class, but make sure you've gone over the Khan Academy video and done a little bit of practice with some of the resources that I put up, because this is a new and kind of challenging concept for a lot of people.